Okay, my name's Ivaylo Kirilov. I work for Web3 Labs, it's formerly known as BLK.io, and I'm here to talk about Ethereum and Java. Yay! Okay, just to set a bit of an agenda today, so I'll be talking about what Web3 Labs is doing, some of the open source projects that we're building out, and hopefully I'll try and give some of the Java developers here some Ethereum background and some of the Ethereum developers here some Java background, understand how Java fits in the Ethereum ecosystem. So to begin with, I work for Web3 Labs. We're about 8 developers, 7 of us based in London, and we have one guy called Sam based in Australia at the moment. More on him a bit later. And yeah, we've been going for about 2 years. We were formerly known as Block.io. What else interesting have we done? Let's see. We've done this, which is a smart contract platform. It's called Epirus. It's got some deployment and developer tools, which come in the form of Web3j, which we'll talk about shortly. And on top of that, you have some management support, business intelligence reporting, analytics, that kind of thing. So you can think of it a bit like a glorified blockchain explorer with some extra bits and pieces in there, something like Etherscan plus maybe, I don't know, except it's written in Java, so that didn't go well. And yeah, the main things about this is it's used in kind of an enterprise setting, so we're targeting enterprises, consortiums and private chains. We support Quorum, which is an Ethereum fork, which allows private transactions. So in our blockchain explorer, you have the ability to view private transactions if you have the rights to view them, which is something cool. Get in touch with me if you want to talk about how we deploy this stuff and the infrastructure that we provide. But I'm going to move on to the cool thing and why I'm here today is to talk about our open source projects and what we're doing to help the Ethereum community and the Java community combine, and the tools that we're providing enterprises to help them build on Ethereum. So some of you have probably heard of Web3j. None of you have probably heard of our libp2p JVM implementation. This is an initiative that we started beginning of this year. So we're looking at the libp2p protocol, which is a communication protocol between ETH 2.0 clients. And it's something we're trying to do a JVM implementation on. Some companies that work, said it last time again, these companies use our tech. So most notably Opera, they're in their Android browser, they're using Web3j. We have a partnership with Microsoft. We're helping build out an enterprise smart contract framework platform for them. And Consensus as well. We have Rob here from Pantheon. Pantheon has been using some of the Web3j code and it's used in acceptance tests there. And lastly, Exim Chain, which is using our smart contract platform registry as a SaaS offering to manage their consortium, essentially, to provide analytics and reporting and business tools. So a bit more on Web3j libp2p. So libp2p itself is basically a modular network stack. Provides a bunch of modules like transport, discovery, connection upgrades. We're kind of in the beginning of it. We started this initiative in January, so we've got like some of the base core concepts implemented, but we're looking to build this out. And our developer, Sam, he's the one kind of pushing this project forward. He's by himself at the moment, but having talks with people like in Protocol Labs that have developed, I believe it's the Python libp2p, correct me if I'm wrong. But yeah, we're working together with other people trying to implement libp2p. Mainly because we're taking a kind of specification-driven approach because the spec for libp2p hasn't been fleshed out fully yet, and we want to make sure that all of the different libp2p implementations kind of work together nicely. Client-centric focus, meaning there's that we don't want to be tied down to like a certain Ethereum client to be able to use our our protocol. We want to, our implementation of the protocol. We want to try and generalize it so anybody can pull out parts and modules that they need. Documentation, test support, and Web3j. As said, we did start in January, so we're trying to build out as much documentation as we can, and being specification driven means that we're also trying to help define the specs that need to be used in Web3 in libp2p. So more about that. You can get some more information on libp2p.io. You can check out the Web3j GitHub. We have the libp2p project there. And then the reference implementation libp2p project. I believe this is in Go. I'm not sure. Yeah, if you go to the GitHub, you'll see a table like this. This table basically shows all of the kind of concepts that we want to try and implement. And you can see some of the core ones we've already done. So like net, peer, crypto libraries for libp2p have been implemented. And at the moment, we're working on the transport layer. So how we're actually going to be sending and receiving packets in our libp2p library. That's enough about libp2p. Web3j is a bit of a bigger topic to cover, so hopefully I'll have enough time. So for those of you that don't know anything about Web3j, this diagram represents nicely how it fits into kind of the Java developing world. You would have your Java application, which can be basically anything you want. And let's say you want to interact some way with the blockchain. Then you'll be using Web3j to make basically HTTP calls to an Ethereum client. And then that Ethereum client will propagate your transaction. And the miners will, at some point, reach consensus on the transaction you've sent in Java to the Ethereum client. So as I mentioned, it's basically a HTTP client. We also support WebSockets, and we also support IPC. We have implementation of the Ethereum wallet. So you can actually create your own wallet with Web3j. It's what Opera does in their Android application. We provide smart contract bindings. I'll go into a bit more detail about that, but essentially you can call contract functions and you can deploy contracts directly from your Java code. So all you need is your Solidity source, and then from there we can convert that to Java, basically generate a Java client for you, which will then be able to call functions, deploy your contract, etc. We have a reactive functional API, more on that in a bit later, and ENS support, so we can get rid of some of those hashes and make it a bit more user-friendly. Currently, we're on Web3j version 4.1.1, I believe, is the most recent version. And in Web3j 4, the difference between 3 and 4 is we've added RxJava support. So we upgraded from RxJava 1, and I'll go into a bit more detail later on. Some various bug fixes, I think is probably not the best term here because we don't have bugs in Web3j. We've done some various enhancements, right? We've made it better. We've tackled more edge cases. BIP44 implementation, so this is to do with how wallets get generated. So you can have like a hierarchical structure of wallets generated from a single private key. And Pantheon support, which is the new Java client written by Pegasus team in Consensus. So for those Ethereum developers that are not Java developers, just to show you how easy it is to get started with Web3j in Java, you'd create a Web3j object. We have a factory method, so you can build your Web3j object and you pass in a HTTP service. This can also be a WebSocket service or an IPC service. We also support Infura, so you can connect via Infura to use the Infura node in your Java application. And then you simply call methods. We try and adhere to the Web3 specs. So here you'd call methods like web3j.ethSend transaction, web3j.web3 client version, web3j.personal unlock account. And then you have 3 different options on how to send these requests to the node. You can send them via blocking call, which means that the application will wait until this call returns a value before continuing. You can send it asynchronously, which means that the application won't block when you make the call, and at some point in the future, you can get the result. If the result is available, then you can use it. And then the Flowable API that we have, which I'll go into a bit more detail later on. This is a nice diagram to show you in a bit more detail how Web3j is actually working behind the scenes. So in Ethereum, you have basically 3 types of transactions that we like to categorize in. You can transfer Ether, which is basically the simplest transaction type. You can deploy a contract, and you can call a function in a contract. We decided to split these up because essentially you'll call the deploy only once, and then the functions you can call multiple times, so it's a different type of transaction. And then in Web3j, what we do is we build a transaction from the to address, i.e. the address you want to send your transaction to. The data, which can be empty if it's a transfer, or the EVM bytecode if it's to do with a contract. So it's actually the EVM bytecode to deploy the contract, or the EVM bytecode to call a function in a contract. Your nonce, or actually the value, which is the value of Ether that you want to send. The nonce, which is the transaction count of your address, essentially. The nonce is used to generate contract addresses. So when you want to deploy a new contract, your to value will be empty. And then using the nonce and the sender address, a contract address will be generated. And then the gas price and the gas limit. Does anyone want me to go over gas? Because it's been it's a topic that people don't fully understand, but it looks like there's no takers. So if anyone wants to know more about gas, and I can get into the specifics of how that works in Ethereum, then you can catch me after the talk. So after we have this data, we sign it with your private key. Then you have your signed transaction, which is sent to an Ethereum client. That Ethereum client, which can be Geth, Parity, Pantheon, or any other Ethereum client that supports Web3 specification. That client will then propagate your transaction. The miners will reach consensus, include it in a block. And at the same time, in Web3j, a transaction manager is created for your transaction. And that is essentially polling the Ethereum client for the transaction status. And at some point when your transaction is included in the blockchain, you'll be returned a transaction receipt, which will hold things like the contract address if you're creating a contract, the events, and the status, for example, of your contract. So yeah, sending Ether, the first type of transaction, we have a utility class with a static method to make it very easy. So you would create your Web3j instance, which will connect to a node. Then you'll load up your credentials. You can load up your credentials from a file, from a wallet file, or you can generate a new wallet file, or you can load up credentials from some kind of mnemonic that you have, because we have BIP44 support. And then using Web3j and the credentials, you can create a transfer. You pass in your Web3j so that we know which node you want to talk to. You pass in the credentials so we know who's sending this Ether. You pass in the to address, so who do you want to send it to, and then the value and the unit. So we support units between all the units between Way and Ether. And obviously you don't want to send 0.2 Way because you probably can't pay for the gas to send that in the first place. And this is a blocking call, so this will wait until the transaction receipt comes back, and then in your transaction receipt you have some information that you can then print out or use however you see fit in your application. You can also do this via the command line. Nobody really uses the command line utility. I use MetaMask myself because I think it's a lot easier. If you want to be cool, you can use the command line utility. It's got options to send Ether. And it kind of works behind the scenes in the same way. Basically, this code gets generated with the correct inputs, and then you get some feedback from the node, whether your transaction was successful or not, which block it was mined in, etc. And then you can go off to Etherscan and check it out if it's working or not. Smart contracts. For those of you who are Java developers and don't know anything about Ethereum, smart contracts are written in a language called Solidity. Similar in concept to Java. It's a statically typed high-level language, similar to Java, compiles to Ethereum, to EVM bytecode, which is then run on an Ethereum virtual machine. Again, similar to Java, how it's compiled to JVM bytecode, and it runs on a Java virtual machine. So with Web3j, what you can do is you can create Java wrappers for these contracts, which is essentially a client that will have all the functions that are in your contract. So you can call your functions in Java as you would call them in Solidity. Just to give you an example, this is like a very simple hello world kind of example. You have a Greeter contract, which extends mortal. In Solidity, the keyword is. In Java, it extends, same thing. And then you have this constructor, which takes a greeting, and it sets the greeting field. And then you have a getter function, which then just returns the greeting field. So you'd compile this contract using the Solidity compiler. You'd pass in the source code, some flags, and then your output directory. And then this will generate an application binary interface and some EVM bytecode. The application binary interface is essentially an array of all the functions that are inside your contract. So for example, you can see that this function has a name called greet. So this is our greet function here. And the outputs are a string and there are no inputs. And then you can also see that the constructor here says type constructor. It's a different type of transaction, a different type of method, sorry, that is in Solidity. So the constructor you can only call once in your contract, and then you can't call the constructor again. Obviously, you can construct a new instance of your contract, but the instance that you constructed, you can't call the constructor again, the constructor method. And the inputs for this is the greeting that we then return in the greet function. This is what bytecode looks like. Doesn't look too interesting. Something that maybe not a lot of people know in this room, every contract has these bold bits in them. And these are essentially flags to show you where this contract is stored in the EVM. So this is the swarm hash of your contract. So this is where it's stored in Swarm. And then this part is to define what kind of storage you're using. So in this case, it's using a Swarm hash. So here it would say Swarm. But if you are using IPFS, for example, here would be the encoding of IPFS. This is the Keccak hash of literally Swarm v1, I think. And then this is the actual Swarm hash. So here you'd have the literal hash of IPFS or whatever other storage mechanism you want to use. And then with Web3j, what we do is we generate the smart contract wrapper, which is this client, which I'll show you an example of in the next slide. You pass in the binary so that we know the bytecode to send in the transactions you want to call methods to your contract on. And you pass in the ABI so we know the names of those methods and we can make it more user-friendly, essentially, easier for developers to understand what functions are being called. Then you pass in the package you want it to be generated in and the outputs directory, and this will generate a file similar to this. Now, this version is generated with an old version of Web3j, so some of the syntax is a little bit different, but you get the general picture. You have here a deploy function, and this deploy function takes in the greeting that we want to put in. So in Web3j, we have a DSL to interact with Solidity types because they're slightly different to Java types. For example, you have 256-bit integers in Solidity. You don't have that in Java natively. So we have some wrappers around those types. But in the newer versions of Web3j, we've actually hidden this implementation. So you don't actually need to interact with Solidity types. You can just use the normal Java types. And build transactions, and they'll be converted behind the scenes by Web3j, so you can use them. And here's like the greet function. So the greet function that takes in doesn't take in anything. It doesn't have any parameters. So we build this function. This function is part of our DSL. So it's not the function as in the Java function. And it takes in the name of the function, the inputs. Which is nothing, and then the outputs, which is a type reference of a string. So we know that the return is a string, and then this function has a method to be able to create the EVM bytecode that you need to call this greet function in a transaction on the Ethereum blockchain. So this is just a simple hello world kind of Web3j blockchain example. We create the Web3j instance, we load our credentials, and then we can deploy our contract using Greeter.deploy. So Greeter is now a Java class, and you call deploy. You pass in the Web3j credentials, so you know which node you're deploying to, you know who's deploying from, your gas provider, your gas price, and the last thing is the input parameters for your contract. And then you can call the Gree function or any other function in your contract, just as you would in, like if you were using the JavaScript kind of version, and then you can print it out and you can see we passed in hello blockchain world in the constructor, and we get returned hello blockchain world when we call the Gree function. One thing I'd like to mention, which I haven't really mentioned in any other of my talks, is that we have a Gradle plugin. So for those of you who know about Gradle, this is really cool because it means that you don't have to worry about compiling Solidity code and you don't have to worry about generating smart contract wrappers. How this works is basically you apply the Web3j plugin. You define a source set. So this is the directory where you're putting your Solidity files in. By default, it goes to, I believe, source main Solidity. So it's in kind of your main project code area where your Java code is. And then every time you build the project, your contracts will be compiled and small contract wrappers will be generated for those contracts. And because we're using Gradle and it's got kind of what's the word I'm looking for? Incremental builds. So if you don't change anything in your Solidity file, then it won't waste time regenerating and recompiling your contract. And then we have some variables that you can play around with, like for example, the generated package name, generated files base directory. So where do you want the generated files to be? Whether you want to exclude some contract. So say you have some contract that is only meant to be used by other contracts that are extending it. Maybe you don't want it to be callable in your Java code, so you can exclude that contract from the plugin picking it up. And then you can run Greeter.bi build inside the source directory to build your application, which will compile your contracts and it will generate these small contract wrappers. Onto RxJava. I know I'm running low on time, so I'm going to try and wrap things up shortly after this. So the Flowable API, the way it's different to send async is when you send async, your program sends the transaction, then it continues executing. And at some point in the future, when you need the value, you would call get on your initial send. And if the value is present, you'll get a value back. If not, you'll get an error. So the Flowable API basically allows you to define kind of like a callback function. So whenever this function Web3 client version returns a value, then it will execute this block of code, which makes it a bit easier to work with kind of asynchronous programs. You can build more complex things. For example, we have some pre-built flowables already in Web3j. So if you want to replay all previous blocks and future blocks, we have a replay past and future block flowable. Define your start number, and then you define whether you want your full transaction objects. This is a flag, which is either true or false. And what it means is it will either return the full transaction object or just the hashes of the transactions in the block. Which might be useful for things like latency and bandwidth critical situations where maybe you don't need the full transaction object, so you would pass in false there. And then for every block, you can do whatever you want with it. This is something our smart contract registry uses behind the scenes. It essentially copies all the blocks from the blockchain into a database, adds some metadata, and then we have a very powerful API to be able to query things and decode things on the blockchain, so it's not just hashes everywhere. Just an overview again of the whole Web3j ecosystem. So at its core, it's a JVM-based kind of Ethereum HTTP client. It's written in Java, which libp2p is also written in Kotlin. which means that they're Android compatible. We also have a version of Web3j which compiles against Java 6. So we support over 98% of Android phones that are out there. And of course, not to forget the Scala community, we can also work with Scala because it's a JVM-based library. The build tools are the Gradle build tool that I mentioned. We also have a similar one for Maven. Client support, Geth, Parity, Pantheon, and we also have a dedicated Web3j quorum library, which allows you to do private transactions, set up private networks and private consortiums. And we also have some framework integrations, namely with Apache Camel on our DSL. We have a Spring Starter project, so you can get started with Spring and Web3j very quickly. And most recently, I think actually on Friday, I completed integration with Climatics Ion interoperability framework, which is a cool kind of small contract-based cross-chain framework to be able to move data across chains, essentially. So we have like a Web3j starter project, which already makes it easier for you to get started with Ion, so you don't have to worry about what's happening behind the scenes. And this is what our GitHub looks like. Come check us out, github.com/Web3j. We have the Web3j library, which has a good number of stars and a good number of forks and a good number of issues as well. So if anyone wants to work on some issues while they're here at EthCC, then it will be a good place to start. Quorum, Web3j, Spring Boot starter project, Maven plugin, Gradle plugin, and we have a sample project, sample Gradle project as well, which is just a very basic kind of hello world Java and Gradle project. And somewhere on there is also Web3j Ion down the list, but I didn't have space on the screen. The future of Web3j quickly, if time permitting, EIP 712 support, which is basically some endpoints for signing structured data. So we have like a sign structured data, I think it's called endpoint, something that we're implementing. We've tried to architect Web3j so it's easily extensible. So when new specs come out, new definitions for new endpoints come out, it's very easy to update them. Pretty much anyone can update them. We want to add support for the experimental ABI encoder to allow us to build more complicated smart contract wrappers. Solidity 0.5 support is pretty much there. There are just some edge cases that we haven't been looking at. We don't have time to look at. So if anybody is actually using Solidity 0.5 contracts and is a Java developer and you've run into problems, then please let us know so that we can make some bounties for this in GitHub. We're working with Gitcoin to make some bounties for issues that we don't have time to fix. And we also want to create some EEA compliant calls as well, like to be able to send private transactions across any EEA compliant client, such as Pantheon. And yeah, thanks for listening, everyone. Web3 Labs. I've got some stickers and some cards, some business cards down at the front. And I open the floor to some questions, if anyone's got any. Any questions? Anyone listening still? One person listening, yes. Good stuff, guys. Or was it just that you were listening? You don't have a question? Ah, you do have a question. Okay.
Hello? Can you hear me? Well,
I can hear you.
Doesn't work. That's fine. No, I was just wondering. So you were talking about the transaction manager that pulls the blockchain to basically get yeah, that's the one.
Yeah.
Is it? I suppose that it's probably not supported in JSON RPC, but can we imagine? I mean, is it planned in the future to avoid having polling the transactions and have the blockchain kind of push these events to?
That is an interesting question. It's not something that we can really do in Web3j without some. Yeah, we need some kind of. Oh, that's a good idea actually, potentially. But you still need to poll the node. We need the node to be able to support pushing transaction receipts back to the client. But the thing is with this poll is set to default to poll every 15 seconds, which is the block time in Ethereum. Obviously, in private and consortium chains, your block times might be lower. So this is a configurable value how often to poll. And we generally think that polling every 15 seconds is not an issue. And there's no point in polling any faster, especially on mainnet, because you're not going to get any new information. So we think it's a sensible default. But pushing, if the Ethereum client could support pushing back a transaction receipt, so maybe providing a callback URL in the send, so that the Ethereum client can then make a request to that URL when it's finished processing the transaction, then that's basically the way to go to provide what you need or what you asked for. Anyone else? Yeah.
Just to let you know, in a framework integration topic, we did an integration with App Inventor.
Yeah.
App Inventor is something where you're able to build a mobile application using a Scratch-like language.
Okay.
You move blocks. And so we did a block which encapsulate the Web3j functionality accessing the blockchain. So people can do easily mobile application using Web3j.
That sounds awesome. I'd like to have a chat after everything goes. That would be good. It wasn't really a question; it was more of a statement.
Yeah, that was a comment.
But yeah,
and we
awesome
have a appinventor.ethereum.org if people want to know.
Awesome.
Try.
We'll catch up after. Any other questions? I think I'm over time, so if anyone wants to grab me after the presentation to have a chat, then feel free to do so. Thank you.